Okay, we're going to begin factoring difference of squares. And the reason we have a squared minus b squared is because you have to have a subtraction, a difference. And if you take the square root of a and b, you're going to get a plus b and a minus b. So what are squares? 1, 4, 9, 16, 25, 36. All of these are squares. Why? Because when you take the square root of like 16, you get a whole number. It's 4. And it's plus or minus 4. So let's begin with this one. So here you're just going to take the square root. That's going to be n plus 7 and minus 7. Remember, multiplication is commutative. So you could have n minus 7 times n plus 7. Okay, and you only have to write it one way. It's fine. So we take the square root of that. That's going to be 4x plus 3, 4x minus 3. And don't forget your parentheses. This one, you have to, you can't take the square root of 2 or 50, so then I'm going to factor out the 2. So backward distributive property. So if I were to multiply 2 times x, that's 2x squared. 2 times 25 is 50. Okay, now this is a difference of squares. So that's x plus 5, x minus 5. So then that's what you do right there. This is your answer. You can take the square root of 81 and 4, so that's going to be 9m plus 2n times 9m minus 2n. And then this one is y to the 4th power. So when you take the square root of that, that's going to be y squared plus 4. If you take the square root of 16, that's 4. Y squared minus 4. But then this one, you can still factor again because that's a y squared minus 4. It's still a difference of square. So this one stays the same. But then you take the square root of those. That's going to be y plus 2, y minus 2. So this is factored completely right here. This is halfway done. This is completely. Okay, so that's factoring difference of squares.